into topic 5. And topic 5 takes us into dealing with radicals. Okay. Today we're looking at radicals and specifically how radicals relate to rational exponents. Now, radicals. When I say radicals, do we know what I mean by radicals?
What?
Not the least bit disturbing there. Let's hope this locker fixes quick. Okay, radicals. Do we know what I mean by radicals?
Gonna tell you. No.
So I probably shouldn't throw that word out there because we know what it means, right?
No.
Okay. So radicals, you start to see them as you, well, on the back side you see them a little bit. When I say the word radicals, I'm talking about square roots. But I'm not just talking about square roots because we're going to talk about square roots, cube roots, fourth roots, fifth roots. So when I throw out the word radical, I'm talking about the square root symbol. Except that it's not just necessarily a square root. It also is a cube root or a fourth root or fifth root or whatever. Okay. I think we mostly will go up through fifth roots. Okay. So, but we're looking at how those relate to our fraction exponents. Okay. So that is our big thing today. Now, when I say square root, what do I mean to take the square root of something? Square root of 25.
5.
Why?
Because it's 5 times 5 is 25.
Okay.
There's a number times
So, okay, there we go. Number times itself is what I'm looking for here, right? So when we talk about square roots, number times itself. Now, I'm going to go a little past square roots, though, because square roots are old hat to you guys. What about cube roots?
The number times itself 3 times.
Okay, so if we're trying to find the cube root, and this is why I suggested you have calculators out today, because unless you know these, you're going to have to do a little bit of work to find them, okay, or process through them. So thoughts on what we're trying to find any real cube roots of 125?
I got it.
25 or 5.
5.
Okay. Why are we suggesting 5?
Because 5 times 5 is 25, and then 25 times 5 is 125.
So the idea,
Okay, did you? Yeah. Who? You did?
okay, to have a little bit, to write a little bit down here, the idea that we talk about cube root, we're looking for something 3 times. So 5 times 5 times 5 is 125. So thus, what is the cube root of 125?
5.
And that is 5. Now, we are specifically looking for real cube roots here. Okay? Officially, there are also 2 imaginary cube roots there that we can find. I'm not going to worry about that because we're just focusing on real stuff in this lesson. But there are a couple of imaginary cube roots of 125. We're not doing them.
Would negative 5
Are you ever gonna do
it?
Would negative 5 be 1? No. Okay.
Okay, so I want to address Aaron's question. Would negative 5 be the cube root of 125?
I see a negative right here.
Negative 5 times negative 5 is
25.
positive 25.
Oh, times.
Times negative 5 takes us back to
Well, I didn't know.
negative 125. Okay, so, yeah, so our only real cube root of 125 is 5. Okay, let's mix it up. Let's talk about fourth roots. I want any real fourth roots of 16. What do you think, Landon?
2.
Why 2?
2 times 2 is 4. Times 2 is 8. Times 2 is 16.
2 times
Okay.
2 is 4. Times 2 is 8 times 2 is 16.
All right.
Okay, so the idea that 2 to the fourth is 16. What if I say there's another real one out there?
Oh, yeah? Negative 2.
Does negative work this time?
It does.
Because what happens when you raise a negative to an even power?
It stays
Cancels. Negative out.
positive.
It becomes positive, right? Because a negative times a negative is going to be a positive. If I look at the other 2, negative times negative is a positive. And then I've got all positive. So, negative 2 to the fourth is also 16. And so with that in mind, what are my real fourth roots? I'm going to write mine as plus or minus 2. If you wrote it as 2 comma negative 2, is that correct?
Yep.
Yes. I will say when I practiced in the homework, Savas was willing to accept plus or minus. So that would be something to be aware of there. Okay, so real fourth roots of 81. What are you thinking?
3.
Okay.
Plus or minus.
3 times.
Since we're talking fourth roots,
3 times.
3 to the fourth is 81. Okay. And
3 to the negative 4.
I know what he meant, but he sure didn't say it right. Okay. So when we're working with these even powers, you can raise a negative to an even power, and it goes back to a positive. And so my real fourth roots here are plus or minus 3. I heard someone accidentally throw out 9. What would 9 be?
Second.
It's a square root, right? Okay. So, and one last one here. Real cube roots of 64.
4.
4. 4.
4 times 4 times 4 is 64. Anything else?
Nope.
Okay. There would be 2 imaginary, but again, we're not talking about that. Negative 4 doesn't work. Now, what if this said real cube roots of negative 64? Then we'd want to use negative 4. And I probably should have thrown a negative in here, but I didn't, so. Okay. Now, did a lot of you guys use trial and error to find those numbers? Or do you know how to use your calculator to find cube roots and fourth roots?
I know how to do that.
Because your calculator will do these. Do we know how to do that? Should I teach that? Should I not?
You taught us before.
Have I taught it before?
You taught us the other way around. You taught us how to do the good. Oh, I'm wrong. You taught us how to do the square root of. Like,
Well, I don't remember. I honestly, here's what I will say. So, any scientific calculator, which is what you guys should be using, right? Which, by the way, there's calculators up here. You don't have one. I would have one in front of you. You're going to need to know how to use a calculator this semester. Okay? You're going to need to know how to use a scientific calculator. Did I get mine up on the screen here? Okay, so if you're using one of mine, it looks like this, and I know a lot of you have this one, but right here is square root, yes?
Mhm.
And so to do the second function there, I do the square root. Up above it, mine is an x root, yes?
Yeah.
Is that an x? Okay, mine is an x root. That means I can do any root I want. On this particular calculator, every calculator works a little differently. I'm going to type it in. So if I want to do the fourth root of 81, I'm going to put 4 first, indicating I'm doing the fourth root. And then I'm going to do my second function and the x root. So this is saying I'm going to do the fourth root of whatever I type next. So if I want to do the fourth root of 81, it tells me 3. Now, it's not going to tell you plus or minus 3. Okay, the calculator's not that sophisticated. But it will tell you the 3. Okay, so all of these problems we just did, you could have done on the calculator as well. And some of you were. Some of you did more of a trial and error thing. If you have a Casio, it's going to work a little bit differently, but you have these buttons there also, yes? Okay. So, did you find where to do yours?
Oh.
Okay, because yours should be in the math menu on that calculator, I think. So, okay, now, I can help you figure it out if you can't figure it out on your calculator. But play around. Okay, it is there. Okay? Okay. I kind of have a summary over here. For odd roots, there's always one real root. And that root will be, the sign will be the same as the base. So like I said, if this had been the cube root of negative 64, my answer would be negative 4 instead. For even roots, so your square roots, fourth roots, sixth roots, so on and so forth. There are going to be, if it's a positive base, there's always going to be 2 real roots. Okay, so thus the plus and minus. If it's a negative base, what's the square root of negative 25? Square root of negative 25. What's my calculator say the square root of negative 25 is?
Air.
There. Because can you multiply a number by itself and get a negative? Okay, and so this is the idea that if you're taking the square root of a negative, we can't do it. It's going to be no real roots. Okay? Okay, moving along. Oops. We're going to spend a lot of time today, and it carries into the next lesson, of looking at how these fractional exponents relate to our radicals. And I've got a connection right here for you. That if you see something raised to the x raised to a 1 over n power, realize this 1 over n power is equivalent to saying the nth root of that base. So the nth root of x. I don't remember if you would have seen this in Algebra 1 or not. It's very possible, but it's also possible you didn't see it. So, but these are rational exponents. They're fraction exponents, and we need to know what they mean. The fancier version, the easy version is when there's a 1 in the numerator. Fancier version, when you have m over n. Well, that means your denominator is always your root, so it's telling you what the index is there. So it's the nth root of x to the m, so that m being the power. And I have it written in two different ways. It could also be the nth root of x raised to the m. So we're going to work a little bit with, okay, what does this mean? And evaluate. Like, what does this simplify to be? So, 16 to the 1/4 power. Thoughts? What do I mean by 16 to the 1/4 power? I know it's a fraction exponent, so I know it has something to do with a radical.
4.
Where's that 4 go?
Left.
Yeah, that's officially what the vocabulary is there. It's my index, but it tells me what root I'm taking. And then 16. So 16 to the 1/4 is the 4th root of 16. So we're being asked to do the 4th root. What is the 4th root of 16?
2.
2?
Oh, 2 is plus or minus 2.
Okay. Officially, though, I actually just want 2 here. Okay.
What?
Now, here's the difference. Anytime we have a radical sign here, okay, so this is a fractional exponent radical sign, they only want the positive answer. If they wanted the negative answer, they would put a negative sign out in front of the problem. So the only time you're going to use the plus or minus, the top part of the paper, we use the plus or minus because it put it in words. We want all real whatever roots. That's when we use the plus or minus. If they are asking you to simplify fractional exponents or give you a radical, they only want the indicated answer. So only the positive or the negative. Okay? So B. Can you do B?
Mm-hmm.
What does 25 to the 1/2 mean?
25 to 2.
Okay. So 25 is under the radical. 1/2, so that denominator of 2 means this is a square root. Now, do I really have to write that little 2 there? No. If there's no number there, you guys know, this is old news, that that's a 2. So this is indicating a square root. Okay, and what is the square root of 25? 5.
5.
Okay, C. Let's get a little fancier here. I have 27 to the 2/3. So I see a fraction exponent. I know I need to think of it as a radical. I know what number is under the radical? 27. What about the 2/3, gentlemen?
It's cubed. It's cubed.
Okay. My denominator 3, says that this is going to be a, he said cubed, but I'm assuming he means
3, yeah.
cube root.
Yeah.
The denominator says it's going to be a cube root. What does that numerator of 2 say?
It says.
Couldn't tell you. I didn't look
It says.
Huh?
2/3.
The numerator says it's going to be a power.
Oh.
So now, we can do this one of 2 ways.
Kidding me?
Now, I'm going to do this the way that I don't have to pick up my calculator. Because I can do this very easily without picking up my calculator. We have an option here. These are equivalent statements. I could do this one and do 27 to the second. I don't know that off the top of my head. And then I can take the cube root of 27 to the second. Your calculator can do that, yes? Or I can use my brain. This one says, okay, what's the cube root of 27?
Boom. Got it.
I don't know if we've talked about the cube root of 27 yet, but it's one you'll become familiar with. What's the cube root of 27? 3. And then what do we do with 3? Square. What's 3 squared? 9. So once you get familiar with some of these, like for instance the cube root of 27, do you need a calculator for this one? No. Now, did some of you do 27 squared and then cube root it? Sure, maybe you did, and that's fine. But here's my point. Order doesn't matter. You can do the power, then the root, or you can do the root, then the power. I always look for the easiest way. To me, I know the cube root of 27. I don't know 27 squared. So it's easier to do the cube root for me.
So is it a cube root then that you said?
Okay. And again, some of these numbers we haven't talked about very much. First time through it, as you become more familiar with these numbers, it'll be easier doing without a calculator. So, okay. What's D mean? 32 to the 2/5.
Well, what you gonna do? Put 5 and then that little squiggly line thing. Yep, put 5 on the left. Throw 32 in there. And square root it.
You don't mean square root it though.
Add the 2. So yeah, square root.
So I can write this as the 5th root of 32 squared, or I can write this as the 5th root of 32 and then squared. It doesn't matter which way you write it. You can do it either way. I personally know the 5th root of 32. And it's one you'll become familiar with the more we work in this chapter.
It's 2.
The 5th root of 32 is 2. And then what's 2 squared?
4.
Okay, 4. The other option, I don't know, did some of you do 32 squared and then do the 5th root of it? The calculator can do that for you. My brain's not going to do that, but the calculator can do that for you. Okay, so important as this is kind of the beginning, as we start to go through this chapter, that you correlate, okay, how do these fractional exponents work? Okay, down at the bottom, we're just evaluating a little bit more. So, 32 to the 3/5. What do you know? It's what? The what root? 5th root, because 5 is my denominator. 5th root of 32 raised to what power? 3rd. I tend to lean towards doing that root first if I can. What is the 5th root of 32?
2.
We just talked about it a moment ago, right? What's 2 to the 3rd?
8.
8. 2 times 2 is 4. Times 2 is 8.
How do you do that?
Times 2 is 4. Times 2 is 8.
The 2, because it's a 5th root of 32. I did the 5th root of 32, which is 2. So basically I did inside my parentheses. And then I did 2 to the 3rd.
First.
You did what?
I said I did not pay attention to that out there, but I got
Okay.
the same answer. I just did that.
Did you do 32 to the 3rd and then the 5th root?
Yep.
And it works. You get the same answer,
It did work.
but that definitely requires a calculator, doesn't it?
Yeah.
So, okay, B. I don't know if you guys can tell.
Negative in there.
It's negative.
There is a negative in there, yes?
Is that error?
And no, there's supposed to be a negative. I know when I printed it out on my screen, like here, I can see a little gap. When I printed it out on there, I don't know if the gap's really showing. But notice it's an extra long fraction bar out to the front, so that is a negative.
There is a gap like this.
Okay. So, okay, dig deep in your brains. We've got to deal with that negative exponent first. How do we deal with a negative exponent?
You don't. They're just drawing that.
Error.
No errors. We deal with it. Come on, guys. Remember, what's the exponent rule? We'll review it actually in the next lesson tomorrow also. But
Positive negative.
where can a negative exponent go to become positive?
Imagination.
Oh, it's the denominator.
The denominator. Does that sound familiar? To get rid of a negative exponent, in other words, here's the deal, guys. I'm not going to work with a negative exponent. I need to get that negative off the exponent before I work with it. So I'm going to move 27 to the 2/3 to my denominator. Okay, we've done this year. We've done this at other times. At least I think we have. No? Not this year? Oh, okay. In my brain, we had done this year, so
No.
Are we still doing it in algebra?
not this year. Okay. Well, I'm getting a lot of head shakes saying, yeah, no, this is not familiar. So negative exponents, guys. In order to get rid of a negative exponent, you move it to denominator. As I said, we'll review more of this in the next lesson. Now, 1 over 27 to 2/3. Can we work with 27 to the 2/3?
Mm-hmm.
Yeah. So I'm going to think 1 over. I'm going to put 27 in the radical. What kind of root of 27 is it? 3 is the denominator. So it's a cube root of 27 raised to what power? Raised to the power of 2. So I'm always going to do the root first. At least if I can. What is the cube root of 27?
3.
3. So what am I doing here? 1 over
32.
3 squared. What is 3 squared? 9. So 1 over 9. That's your answer. Okay. Then no, I don't want a decimal answer or anything like that. Savas won't want a decimal answer. We want fraction answers with what we're doing right now. Okay, C. C has a negative out front. It's just a single term, so I can't distribute. Otherwise, I might consider it. If there's a negative out front, what's that mean about my answer? No, if there's a negative out front, my answer is just going to be
A negative.
negative. With this particular problem, that negative is out front. It's even outside of the parentheses. We're just going to carry that negative down. Okay? So I'm going to do the negative. 16 goes under the radical. What's my root here that we're doing?
Well,
The denominator is 4, so it's going to be the 4th root. What's the power we're going to raise it to? 3, because the numerator is 3. So, again, if you want to do 16 to the 3rd and then take the 4th root, work that calculator. That's fine. You'll get the same answer. Some of you have tried it. That's good. I'm going to go with what's the 4th root of 16? 2. And then raise it to the 3rd. What's 2 to the 3rd? 8. So what's my answer? Negative 8. Okay. Got 2 more sections on back. My plan is that, yes, I should finish these notes today, and that will make homework due tomorrow. Okay, so that is my plan. On the back, we're going to work a little bit more with this whole fractional exponent thing, okay? What we need to talk about, and I don't think I had any variables on the front page, but the majority of your homework says with the variables, assume that the variables represent non-negative numbers, I think is how they phrase it. Okay, so that just means work the problem, plain and simple, nothing fancy. The catch is, if it doesn't say that the variables are non-negative, you might have to use absolute value, because here's the deal. Can we take the square root of a negative value? I think I tried to do that up here, didn't I? Yeah. I tried to do square root of negative 25. It didn't work, did it? We can't do the square root of a negative number. And so, in the case of a variable, we might have to use absolute value bars to ensure it is positive. And so it doesn't happen a whole lot in homework, but it happens a little bit. And so what this is saying is that when you do the nth root of some variable, if you're doing an odd root, so a cube root, a fifth root, a seventh root, it doesn't matter, because we can take the cube root of a negative number. So that's fine. But if we're doing the square root, fourth root, sixth root, some even root of a negative value, or if it could be negative, we have to put absolute value bars to ensure it's not. Okay, so I'm going to explain that as we go through these. But we're going to start with what we're doing on the front side, except now there's variables. Okay? Simplify each expression, use absolute value bars when necessary. Think about this as two pieces. Think about this as the fifth root of 32 times the fifth root of m to the 15th. Okay. Can you do the fifth root of 32? I think we've already done it a couple of times today, haven't we? Fifth root of 32 is 2. Now, the fifth root of m to the 15th. How can I rewrite this with a rational exponent? In other words, how can I take this out of radical form and put it in exponent form? So basically go the other way from what we were doing on the front side. So this is going to be m to what power? I think I heard it.
15 fifths.
Okay. Yeah. I'm going to start by saying 15 fifths, because what do? The root of 5, that index of 5 is the what? It's the denominator. Your power, the 15, is the numerator. So your brain can think through this as m to the 15 over 5. Now, am I going to leave it as 15 over 5? No. What is 15 divided by 5? 3. So those of you that said m to the third, you're not wrong. I just took an extra step in there to make sure that we see where that m to the third comes from. Now, in this scenario, do I need to consider absolute value bars? No, because here's the deal. What do we know about 5? 5 is odd. Are you allowed to have negatives when odd? Yeah, you can have negatives in it. That goes back to we can take the cube root of a negative, the fifth root of a negative. So this one, no absolute value bars. We are done right there with 2m to the third. Okay. Next one. Fourth root of x to the 20th, y to the 8th. Thoughts on how I can rewrite this? X to what power? There's a power of 20 and an index of 4. So how am I going to put that?
20 over 4.
20 over 4. Okay, power always stays on top. Index goes in the denominator. Y to what power? 8 over 4. You're always taking your power and dividing it by the index. Well, does this clean up? x to the fifth, y to the second. Now, I got to take you back to the absolute value question. What kind of root is this? This is a fourth root, which is even. Guess what, guys? Because it's even, we need to consider absolute value. Now, you don't necessarily leave the absolute value on. You have to look at the individual pieces. But I'm going to consider that, oh, hey, I guess I should put it on up there too. I might need absolute value to make sure these are positive. Here's the deal. Could x to the fifth have a negative value? So basically, if x was negative and you raised it to the fifth, could that be negative? It could. Am I allowed to have a negative under a fourth root? I'm not. So we have to, absolute value bars have to stay around the x to the fifth. What about y squared? Could y squared be negative? No, because what happens? If y is negative, what happens when you square it? It becomes positive, doesn't it? If y squared is going to become positive, I don't need absolute value. And I guess I didn't play around with it in Savas to know what happens if you put absolute value on the whole thing. I'm guessing they count you wrong and say, try again. Okay, so here's the deal. It was an even root, so I had to consider absolute value. Where did the absolute value have to go on? Basically the odd exponent. The even exponent would make itself positive and we wouldn't have to worry about it. Okay? Okay. Questions on that before I move on to C? Okay, let's try C. Cube root of negative 8, a to the third, b to the ninth. Well, what do you know here? Am I going to be able to do the cube root of negative 8? Can I do the cube root of negative 8?
No.
The cube root of regular 8 is 2. Can I do the cube root of a negative? Yes, because it's an odd root. Because what happens when you say negative 2 times negative 2 times negative 2? 3 negatives multiply back to be a negative, yes? Okay, so we can do that. We're going to do that here in a moment. How am I going to write a? It's going to be a to what power to begin with? It was a to the third, and we're dividing that power by the index of 3. What about b? It's going to be b to what power? Nine over 3? And you don't necessarily have to write these steps out. This is just me trying to make sure you have it on paper so you can see it. What does this clean up to be? Cube root of negative 8 was negative 2. A to what power? A to the first. Do I have to write that a to the first? No. B to the third. Okay. Do I need absolute value? No, because this was an odd root. If it's an odd root, we're allowed to have negatives. We have a negative. It's fine. Okay? One more in this section, then we got to solve a couple quick equations before class ends. Okay. Fourth root. So we're going to have to do the fourth root of 256. Oops. X to what? X to the (12 divided by 4) and y to the 24 divided by 4. if you're working with a calculator and you haven't figured out how to do the fourth root of 256, are you just doing some guess and check type stuff? Right? And I can help you figure out your calculator if you haven't figured out how to do a fourth root. All of the scientific calculators can do it, I promise. What is the fourth root of 256? 4. Okay. X to the third, y to the sixth. Absolute value. Do I need to consider it? Yes. This is an even root. So even root says, hey, maybe they're not going to stick, but throw some absolute value on there. Okay. Do I need absolute value to make 4 positive? No, 4 is already positive. Okay. Do I need to absolute value to ensure that x to the third is positive? This is if it's an odd exponent, you're going to, because if I take a negative and multiply it 3 times, it would go back to negative. I don't want that. So I do need absolute value around x to the third. Do I need absolute value to make y to the 6th, make sure y to the 6th is positive? No, because if y is negative and I multiply it 6 times, it's going to be positive, so it's good. So I only ended up with absolute value around x to the third. Again, there's just a couple of those in homework, but there are a couple. Okay, got about 5 minutes. We're going to solve equations. These are very basic equations that I'm going to go with you kind of already know how to solve. 2x to the 5th equals 64. We probably solved stuff like this, except it was probably x to the squared. Okay? But if I'm going to solve for x, we want to start by getting x by itself. What are we going to do? Divide by 2. I like it. If I divide the left by 2, divide the right by 2. So then I end up with the equation x to the 5th equals 32. Now, I know the book taught this slightly different because it talked about raising it to a power. I don't want to raise it to a power. How do you get rid of an x to the 5th, you think? Take the, but not square root. It's a 5th power, so we're going to take the 5th root. Okay? Because if it was x squared, we'd take the square root, right? Since this is x to the 5th, we're going to take the 5th root. If you take the 5th root of one side of the equation, you take the 5th root of the other side. Now, the book teaches it, instead of taking the 5th root, you raise it to the 1/5 power. That's still going to be taking the 5th root. So, the 5th root of x to the 5th is, guess what? X. What's the 5th root of 32? 2. That's what? At least the 4th time we've done the 5th root of 32 today. Is it starting to stick in your brain? Okay, B real quick. 5x to the 3rd equals 320. What do we do? Divide by 5. I want to get to C, so we're going to finish. We're going to go quickly here. X cubed equals, what's 320 divided by 5? 64. How do you think you get rid of a cube? If it's x to the 3rd, we're going to take the cube roots. You catching on? The cube root of x cubed is x. What's the cube root of 64? 4. Okay, one last one. Hang on with this last one before you pack up. 2p to the 4th equals 162. What do you know? Divide by 2. We end up with p to the 4th is 81. Then you took the 4th root, and 4th root of p to the 4th is p. What's the 4th root of 81? So the 4th root of 81 is 3. Could it also be -3 in an equation setting? Okay, so this is why I said hold on before you pack up. You do want to throw a plus -3 on there because it was an even root. Okay, your homework should be available In Savas, lesson 5-1, I do have a due date of tomorrow on there. Get it done and we will jump into 5-2 tomorrow.